Hola. Today we are going to be talking about construction proofs. So, first off, quick review. There are things we can use for our proofs. So there are postulates, axioms, and theorems. So postulates are statements of fact. They're factual statements without proof. Axioms, on the other hand, are statements of reasoning without proof. And then lastly, theorems are basically their conclusions based off of either axioms, postulates, or other theorems. So there are 5 different ways to find congruent triangles. The postulated ones are SSS, where all 3 sides are the same. SAS, where you have 2 congruent sides and an angle in between them. And ASA, the opposite of SAS, 2 angles and a side in between them. There are also 2 theorems. AAS, which is a side and then 2 angles not surrounding the side. And hypotenuse leg, which consists of a right triangle and equal hypotenuses. Now also, given an isosceles triangle, so if we have an isosceles triangle like so, the base angles of an isosceles triangle are always equal. So next, topic 2, we're going to be doing something known as the angle duplication construction. So basically, the idea is, if we have, I'm going to draw this up here so I actually have room to do this. If we have like an angle, right? Like say BOA, that's the one we're going to be using later in the video, angle BOA. We can draw an angle identical to that, maybe E, C, and D. That is exactly the same angle. So angle BOA and angle ECD are the same without using like a ruler. We're going to be using a straight edge for this. So what we have to do, first we're going to draw our angle. So we have an angle like so. That's going to be our angle. So we'll have points B, point O, and point A. Now we're going to duplicate this without using any of the number markings on the ruler. I'm just using this because it's a straight edge, but I could use like this side of my phone if I really wanted to prove the point. But I'm not, because that's weird. So the first thing we're going to do is we're going to draw a line, and it doesn't matter how long the line is, just any line, as long as you believe it's longer than this, because it's a line, so it's infinite. And what we're going to do is we're going to take a compass, alright, and we're going to find out how far it is from point O to point A with the compass, so about that far. We're going to take it over here, and we're going to create a curve like so. Then we're going to find the distance from A to B, which looks like it's about that far. And we're going to go from this point here, and we're going to create like a curve like that. And what we can do now is we can mark this as a point here. This is point E. The point where this crosses is point D, and this point at the end of the line is point C. We can draw a line between point C and point E, and it looks pretty similar to the starting angle. Now this one's slightly tilted, but it looks pretty similar. And if you get a protractor, I don't have one on hand here, but you can get a protractor and you'll find that they're pretty similar. So now we're going to do the same thing again, but we're going to prove it as we go. So I'm going to draw a bit of a thinner angle for this. Let me raise my camera up a bit too. Alright. So I'm going to draw new angles. So we're going to draw that is our angle we're going to be duplicating. So we're going to make a 2-column proof chart down here. And because of space with the other angle, like, you're meant to skip lines, but actually, yeah. So you're meant to skip lines, but I'm not, since I don't have enough room on this page, and I'd like to keep it all on one page. So here's what we're going to do, and we're going to do this as we go. So let's mark the points. So point B, point O, and point A, like so. So the first thing, our first statement is just angle BOA, and that's given. Because that's our first step in order to replicate, is drawing the angle we want to replicate. Next, what we're going to do is we're going to draw line CD. Draw line CD, and we can do this because it's a possible construction we can do. Sorry, I said D, I meant H, CH. And we'll have a long line, like right about here, from point C to point H. Misdrew that a little bit, but it's fine. Next, what we're going to do is measure line segment OA with the compass and draw CD. So what this means right here, this is a possible construction. What that step means that we just did is measuring the distance between point O and point A and doing that. And at the point where it intersects the line, this point right here is point D. Next, we're going to construct measure line AB. That doesn't really make grammatical sense, but it's okay. Construct measure line segment AB. And what that means is we just measure the distance between A and B. So, once again, we go boom, and boom, and that's our distance. Again, by possible construction. Next, we're going to construct segment, construct segment DE. So, construct line segment DE. And, again, by possible construction. Most of these are going to be possible construction, which I've already kind of shown. So what that means is that now that we have the distance between A and B, which I think I was actually a little short on that, yeah. The distance between A and B, we put it on point D, and we do that. That's what that means. We construct point E. So we put the point, and that's point E. Now we're going to construct CE because it's a possible construction. Any two points can have a line through them, so let me construct CE. Again, by possible construction. So then we're going to take this, and since we know we can do it, we're going to draw a line through there. Now we need to prove that these two angles are actually the same. We've done the proof of creating the two angles, but how do we know if angle BOA is congruent to angle ECD? It's actually pretty simple. What we can notice is that by measuring, we're going to do this one step at a time. In step 3, when we measured line segment OA and drew angle CD, we knew that they're the same measurement. So these side lengths between CD and OA are the same. So we can write that line segment OA is congruent to line segment CD by inspection of step number 3. Next, we have, by the same reasoning, in step number 6, constructing CE, we know that CE is the same as OB because E and D are the same distance, which puts them at the same spot. So that would make CE congruent to OB by inspection of step number 6. And then finally, step number 5 in constructing DE, we know that it's measuring the distance between DE and AB. So we know that AB is congruent to DE by inspection of step number 5. So if we mark these all off, we'll see. I'm going to just draw this as like a close triangle, because we have the arc, but I'm going to actually draw like the line in here. Based off of all these steps, we have a congruent triangle here by SSS, which is our next step, step number 10. We know that triangle BOA is congruent to triangle ECD by SSS in steps 7, 8, and 9. Those 3 steps marking the sides equal, which means that because they're the same, we know the angle BOA is congruent to angle, that looks like a triangle, but it's angle. Angle ECD by CPCTC, which if you see in my last video, CPCTC means that if 2 triangles are congruent, any given part of them are congruent. So if I knew that these were the same, this angle and this angle are the same. Same case here. Since we know that these are congruent by SSS, this angle and this angle are the same. Bye.